Hello children, today I am back again with a new chapter in Maths, Factors and Multiples. But before that, let's revise what you have studied in the previous months. The first chapter that you had covered was numbers. In that you studied the number system. You have studied how to read the numbers in Indian system as well as in international system. You learnt the Roman numerals. Following that, you studied all the 4 basic operations: addition, subtraction, multiplication and division. I hope so by this time you may be clear with all these topics and you may be thoroughly revising these topics in your home. Please try to complete the classwork copies also, children, by this time. Now, today we are going to start a new chapter, chapter 5, Factors and Multiples. This is totally a new chapter for you. You are hearing the name factors for the first time. Let me tell you what are factors or what factories. Factors are those numbers which divides the given number exactly without leaving any remainder. Let me write the definition for factors first. Factors are those numbers which divides the given number exactly without leaving any remainder. Now, for explaining this one, I have brought some flowers here so that I can explain to you. Here I am having 6 flowers. You can see 1, 2, 3, 4, 5 and 6. Here this I am going to arrange these 6 flowers in any way. But suppose I am going to make a bunch of 2. Okay, I am going to make a bunch of 2. How many bunches I can make? Here this is the first bunch I have made. Here this is the second bunch I have made. You can see this is the first bunch. This is the second bunch I have made. And this is the third bunch. That means I have made 3 equal bunches. This is the first bunch. This is the second bunch. And this is the third bunch I have made. That means nothing is left out. That means I have arranged these flowers 2 bunches of 3 each. 3 bunches of 2 each. Means if 6 flowers are there, if suppose 6 are there, 1, 2, 3, 4, 5, 6, I have arranged 2 flowers of 3 bunches. That means here we are having 2 and 3 bunches. That means nothing is left out. Here 2 and 3 we have seen. That means I can arrange the flowers, 2 flowers in a bunch. No flowers is left out. Now, I can arrange this as 1 flower each. 1 flower each. I will get 6 bunches. This is also one way. Or I can make it as a single bunch. That means 6 flowers in 1 bunch. That means whenever I am doing this, like 6 flowers, all the 6 flowers, 1, 2, 3, 4, 5, 6, all the 6 flowers in 1 bunch, nothing is remaining. Then I have shown you 1, 2, 3, 4, 5, 6. These 6 single flowers, that means 6 single flowers, and I am getting 6 bunches here. 1 single flowers, and I am getting 6 flowers here. That means here, in all these cases, you can see none of the extra flower is not left out. All the flowers are used up. Okay. Now, if I think I am going to make 4 flowers of 1 bunch. I am taking 4 flowers, 1, 2, 3 and 4. I have made a bunch of 4 flowers, but for the second bunch, I am having only 2 flowers. I don't have the 4 flowers here. That means here 2 flowers are left out. So, I can say that this making a bunch of 4 flowers is not correct. It is not proper. It is not dividing this into equal parts. So I cannot, suppose here I am going to explain this one. If I am going to make a bunch of 4 flowers, how much is left out here? 2 is left out. That means 2 is a remainder. So I can't say that I cannot divide these flowers into a 4 bunch and left out 2 there. So we cannot make a bunch of 4 flowers because there you find a remainder. What you mean to say was that there are different ways of arranging, but the thing is that you have to see whether any remainder is left out. If remainder is left out, as I have shown here, if flowers are left out, 4 and 2 you have seen, 4 flowers in a bunch, but 2 were left out. So 4 is not a factor of 6. Okay. So here we have seen, if I am taking 6, we have taken 6 flowers. We have seen if you are arranging it into 1 into 6. Here you get 6 flowers, means 1 each, 1 flowers each. You are getting 6 groups. Okay. When we were making 2 flowers, we were taking 2 flowers a group. How many bunches we were getting? 3. Again, we have used all the 6 flowers. Okay. The same way, you have seen 3 flowers. 3 flowers in a bunch. How many bunches you have made? 2. Again, you have got 6. The next time you had seen 6 all together, and how many bunch you got? 1. That means 6 ones are 6. But as I had shown you, can we make a bunch of 4 flowers? No. Then 2 flowers are left out, and that 2 flowers is a remainder. It's not dividing actually. That 4 is not dividing exactly 6. It is leaving some remainder. So 4 is not a factor of 6. So here the factors of 6 are 1, 2, 3, 6. 1, 2, 3 and 6. So these are the factors. So that means these numbers divide the number 6 exactly without leaving any remainder. You have seen, if I am making a bunch of 1 flower, means if one single flowers, I got 6 bunches, it is equally divided. When you are taking 2 flowers, it is equally divided. We get a bunch of 3. We get 3 bouquets and it is equally divided. We don't get any flowers remaining there over. When you are taking 3 flowers at a bunch, we get 2 bunches and none of the flowers is left out. If you are taking all the 6 flowers at a stretch, we get 1 bunch. Again here none of the flowers is left out. So we can see that this number 1, 2, 3 and 6 divides the number 6 exactly without leaving any remainder. So what I mean to say was that here the definition comes to be proven here that the number which exactly divides the given number, that means these numbers as we have written for 6, 1, 2, 3 and 6. These are the factors of 6. Okay, so once again I am telling what are factors? The numbers which divides the given number exactly without leaving any remainder. That number is called as factors. Okay, now how to find the factor? This was to explain, but how we are going to find the factors? To find the factors, we actually find the pairs of number which gives the product. For example, I am going to find the factors of 12. I am going to find the factors of 12. How I am going to find the factors of 12? For that, we are going to find the pairs of numbers whose product is 12. The first number we are going to write is 1 into 12. We will write from the sequence. We will go in a sequence. We start from the multiplication by 1. We will see by which number when you multiply by 2, by which number you will get 12. Okay. So the next number is 2. 2 into how much you will get 12? 2 into 6 is 12. Yes. Then coming to the next sequence is 3. 3 into what will give you 12? 3 into 4 is 12. The next number 4. After 3 we have 4. So 4 into what? 4 into 3 is 12. Now here 3 into 4 is same as 4 into 3. When it starts repeating, stop there. Now here we can conclude the factors of 12 are 1, 2, 3, 4, 6 and 12. The factors of 12 are 1, 2, 3, 4, 6 and 12. There is no need of finding all the factors here. Next will be coming 6 into 2. It is same as 2 into 6. That's why I told you, when it starts repeating, you can stop there and we can conclude with this 1, 2, 3, 4, 6 and 12 are the factors of 12. Now another example we can see. Take the number, we are going to find the factors of 16. Suppose, again the first number will be 1 because 1 is a multiple of every number. 1 into 16 is 16. The second number, start with 2. Is 16 divisible by 2? Do you find 16 in the table of 2? Yes. 2 into 8 is 16. Okay. Now come to 3. Do you find 16 in the multiplication table of 3 or is 16 divisible by 3? No. Isn't it? Like if you are not so expert in divisibility, you can just, because we have learned the multiplication, so we can see the multiplication table itself. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12 and 3 5s are 15 and 3 6s are 18. We don't find 16 in the table of 3, so we can omit that 3. That means 3 is not a factor. Okay. Now coming to 4. 4, do you find 16 in the table of 4? Yes. 4 4s are 16. Now coming to the table of 6, we don't find 16 in the table of 6. We don't find 16 in the table of 7. Then coming to 8, 8 2s are 16 is same as 2 8s are 16. So we stop it here. The factors of 16 are, now we can conclude the factors of 16 are, factors of 16 are 1, 2, 4, 8 and 16. Here 4 4s are 16, so no need of writing one more 4 here. Just one 4 is enough because 4 is a factor. We are dividing by 4. Now 1, 2, 4, 8 and 16. So these are the factors of 16. So as I told you, to find the factors of any number, you have to find the pairs of numbers whose product, as in sense we were finding 16, we have found the product of some numbers whose product is 16. Okay, and we go in a sequence so that you will never miss any factor. Like you may be knowing that 4 4s are 16, don't write 4 4s are 16 before this one. If you go in a sequence, there is less chances of missing any number or missing any factors. We will see more examples related to factors now. Suppose I am finding a factor of 36. Take a big number, 36. Now, as I told you, the first factor is 1 into 36. Yes, because 1 is a factor of every number. Come to the next sequence, 2. 2 into how much you will get 36? 2 into 18. You can find this by division also. If you are not so proper in multiplication, you can divide 36 by 2 and see. Divide 36 by 2, 3 divided by 2, it is not completely divisible by 1 time 2, the remainder is 1, bring down this 6. How many times is 16 divisible? 8 times 16 subtracted 0, 0. That means 2 into 18 is 36. Now come to the next sequence, you have 3. 3 into how much you will get? 36. 3 into 12 is 36. Yes. Now coming to the table of next, after 3, next sequence is 4. 4 into, yes, 4 into 9 is 36. Now do you find 36 in the table of 5? No, because in the table of 5 you find only the numbers ending with 0 and 5. 5, 10, 15, 20, 25, 30 like that. So 36 you won't find in the table of 5. So leave that. That means 5 is not a factor of 36. Come to the next number, 6. Yes. 6 6s are 36. Next, 7 is not a factor, 8 is not a factor. Coming to 9, 9 4s are 36 is same as 4 9s are 36. So stop it there, and now we can conclude the factors of 36 are 1, 2, 3, 4, 6. Here 6 is repeated, no need of repeating that 6 again. Come to the next number, 9, 12, 18 and 36. Okay, so I hope so you have understood how to find the factors of a number now. So we will see a few more examples. Here you have seen a bigger number. I will take a number like 13. We are going to find the factors of 13. Same way 1 into 13, the first factor of every number is 1 itself. So 1 into 13. Now see, do you find 13 in the table of 2? It is not divisible because it is an odd number. 30 is an odd number, so it is not divisible by 2. You won't find 13 in the table of 2. So leave 2. 2 is not a factor. 3 4s are 12, 3 5s are 15. That means again 3 is not a factor. Coming to 4, table of 4, if you see, 4 3s are 12, 4 4s are 16. We don't find 13 in the table of 4 also. We don't find 13 in the table of 5. That means 13 is not divisible by any number. It doesn't comes in any multiplication table. So here the factors of 13 are 1 and 13. That means 1 and the number itself. So we can see one more example later, like the factors of, I'm going to find the factors of 19. The same way, the first factor is 1 into 19. Okay, we will check out in a sequence starting with 2. Do you find 19 in the table of 2? No. 2 9s are 18, 2 10s are 20. So 19 is not divisible by 2. So leave it 2. Come to the table of 3. Do you find 19 in the table of 3? No. 4 4s are 16, 4 5s are 20. Coming to 5 again, you don't find in the table of 5 also. That means this 19 is not divisible by any number other than 1 and the number itself. So here we have only 2 factors, 1 and 19 only. We have 2 factors. Okay. So we have seen here, in all these cases, whatever numbers we have done, I will write here the factors of 6 also, which we have done earlier. Factors of 6 were 1, 2, 3 and 6. We have found the factors of 16 also. That also I will write 1, 2, 4, 8 and 16 we have found. So going through this, we can see some facts of factors. That here, the first number is, in all these factors you can see, when you take the factors of 6, 1 is the factor of this number. Again you find 1 as a factor of 16. You find 1 as the factor of 36 also, 1 as a factor of 13, 1 as a factor of 19. So we conclude that 1 is a factor of every number and it is the smallest number. Okay, this is the first fact about factors, that 1 is the smallest factor and it is present in all the numbers. That means it is the factor of every number and it is the smallest factor. Now see, here we can find 1, 2, 3, 4 factors here. 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. Means it's limited. Here only 2 factors are there. Can I add more factors here? Can I say that 2 is a factor of this number? No. Can I say that 5 is a factor of this number? No. So factors are limited in number. We can't say that as it is unlimited or we can't put more numbers over there. They are limited and they have an exact number of factors. Coming to the next fact, you can see when you are talking about the factors of 6, 1 is the smallest factor and 6 is the biggest factor, and rest all numbers are less than 6. So children, you have seen these are some of the facts that I want to just tell you. So we have seen 1 is the smallest factor, 1 is the factor of every number and it is the smallest factor, and the number itself is the biggest factor and rest of the factors are smaller than the factors. It is limited in number. Okay, these are some of the facts that I want to tell you about the factors, and please revise this chapter properly and we will meet you next time. Thank you children.